Good morning, dear students. Today we will start discussing about the new topic, nanomaterials. Uh, in this nanomaterial topic, the first of all, you need to know about what are nanomaterials. So, what is a nanomaterials? So, nanomaterial is described as, in principle, the materials which is in a single unit of small size of 10 raised to minus 9 meter in diameter in at least one dimension. So it is having a, the many dimensions will exist from 0 dimension to 3 dimension. So in any one of the dimensions, the material size is in between 1 to 100 nanometer, 1 to 100 nanometer, 10 raised to minus 9 meter. 1 into 10 raised to minus 9 meter into an 100 nanometer size. So such materials are described as nanomaterials. Now, the nanomaterial is as defined as the materials with any external dimension in the nanoscale or having internal structure or the surface structure in the nanoscale. So either the external dimension is in 1 nanometer size completely, or maybe an internal structure of the molecule or an atom, it may be in another nanometer. So you will have a combination of different nanometer, but overall in the nanomaterials, the material size should be lie in between 1 to 100 nanometer with the length approximately from 1 to 100 nanometer. Now the technology, nanotechnology is the study of these materials, various materials made up of atoms or molecules whose internal or external dimension is in between 1 to 100 nanometer. Then nanotechnology is the study of manipulating the matter on an atomic scale. So these different dimensional materials will go on, manipulating itself in the structure, because you know that the Avogadro number 6.023 into 10 raised to 23 the particles per mole or atoms per mole. So many number of atoms with different dimension. So it may be one dimension, 1 nanometer, 10 nanometer, 20 nanometer, 50 nanometer, or maybe 100 nanometer. Putting together all these atoms in different scale is the manipulation. So the term manipulating is the combination of different sized atoms is the whose external dimension or internal dimension is in between 1 to 100 nanometer, clubbing those atoms or molecules in one matrix is the nanotechnology. And upon making those atoms into a material shape, overall property will change, and the study of the entire properties is the nanotechnology. So in the nanotechnology, which deals with the structure size of between 1 to 100 nanometer in at least one dimension. So these atoms or molecules whose dimension is maybe external dimension or maybe internal dimension again 1 to 100 nanometer is arranged in any one of the dimension, is arranged in one dimension, is arranged in two dimension and three dimension, etc., or developing or modifying such materials and studying the properties, the various applications or device properties of those materials whose particle size varies between 1 to 100 nanometer. So entire technology which is involved in grouping different atoms in different nano sized atoms, okay, or molecules in one matrix, and studying or fabricating those materials and studying the device application properties is the nanotechnology. Now what happens when the materials are brought down to nanoscale? So you know that the what materials, what property may increase. So we found that the physical and chemical properties of the nanomaterials are significantly different from the single individual atoms or maybe bulk molecules. Now, when you look into any of the bulk molecules, if you say a bulk carbon, carbon is an atom, carbon is in the form of a molecule. Okay, so either the carbon atom, for example, or the molecule in the bulk molecule, the carbon in the hydrocarbons. Okay, so the properties are fixed here in the bulk scale, but in the nanoscale the properties in the sense the physical properties as well as the chemical properties were extremely different. So how could these differences of these properties arises when the material is brought down to nanoscale from the bulk scale of the materials? Now, when you reduce the bulk scale of the materials into 10 raised to minus 9 meter scale, uh, especially in between 1 to 100 nanometer scale, the spatial confinement of the atoms and molecules takes place. So, spatial confinement refers to the electronic structural arrangement of atoms and molecules. Now, you know very well that carbon. When you look into the carbon in the bulk state, so you will have an s orbital and you will have a p orbitals. So the electronic confinement is fixed in the bulk scale of the material, but in the nanoscale, when you reduce the molecule from bulk scale to the nanoscale, these electronic confinement arrangement of electrons around an atom or a molecule completely changes. So completely random arrangement is takes place. That is what is called as a spatial confinement of the atoms or molecules, and the energy possessed by the orbital also changes considerably. So the s electron energy is fixed in the bulk scale, p electron energies are fixed in the bulk scale, and d electrons energies are fixed in the bulk scale. But when you reduce the molecule from bulk scale to the nanoscale, these energies, energy contained in each orbital will be different because electronic arrangement is different. So different electrons will randomly arrange in different orbitals, and therefore energies in the orbitals are different. Now, once these energy contained in an orbitals are different, electronic structure of the orbitals will also be different. So you will have a hybridization, electronic structure of the orbitals, that is nothing but hybridization. Hybridization, you know very well that regularly you have an sp, sp2, sp3 hybridization, correct? So these hybridization will completely change when the energies of the orbitals will change. That is what is the meaning of electronic structure of the orbitals will change. Now, once the electronic structure of the orbitals will change, chemical reactivity will also change. And once this chemical reactivity will change, you can find an improved optical, mechanical, biological, catalytic, so on. So, the properties of the nanomaterials will be completely different because of the spatial confinement of the atom, random arrangement of atoms or molecules in the space, energies of the orbitals. So different energies of the orbitals are different, and electronic structure of the orbitals will be completely changed, and hence the chemical reactivity also will change, and which improvises the optical, mechanical as well as biological catalytic activity. So properties of the nanomaterials will be completely different from the properties of the bulk materials. So this we'll study in the next course to discuss some of the properties. Now, how small is the nano? So nano, when you look into the nano, when you known things, if you can compare the water, so the units is in nanometer. The water, zero point 0.1 nanometer, glucose, you consider, let us say, nearer to 1 nanometer. Now, antibody, and 10 nanometer, virus, 100 nanometer, bacteria, 1000 nanometer, 10,000 nanometer, cancerous cells. So, nano is very, very small. So, when you compare to the tennis ball, which is like, very, very big. Okay. So, the nano, if you compare, so which is very, very small, is in between 1 to 100 nanometer. So in the scale of 1 nanometer into 100 nanometer, these nano materials will fall. So these nanomaterials are either singly made up of an atoms, or maybe molecules, or maybe a cluster of atoms and molecules. So when you mix atoms and molecules put together, that kind of material is called as a cluster. So you can find different forms of the materials with different size of the atoms and different size of the molecules. Depending upon the size, So nanomaterials will always possess different properties depending upon the size of the nanomaterials. Depending upon the size of the nanomaterials. So either it may be 1 nanometer, 10 nanometer, 30 nanometer, 50 nanometer, so on. Different size of the nanomaterials will possess different properties. Now, when you look into again, consider DNA. Now, when you consider DNA, it is in 2.5 nanometer in diameter. Now, bacteria 2.5 micrometer long, and when you have a large raindrop, it is 2.5 millimeter diameter. Now when you say into say a graphene kind of molecules in nanometers, that's in a 4 nanometer in diameter. The ant is 4 millimeter long, and you can compare different materials which will exist in the nature as compared to the nanomaterials. So when you look into the single walled carbon nanotube, carbon when it is reduced to nano nano state and is rolled into the form of a cylinder, and it becomes a single walled carbon nanotube, and diameter of these carbon nanotubes you can reduce it into 1 nanometer, very small. And when you look into the hair, it is 100 micrometer. So look into the hair and look into the carbon, uncomparable size. When you look into this comparison with the human hair, look into the single human hair, which looks, this is the same scanning electron microscopic images of the hair as well as the nanofibers. So when you look into this image, you can very clearly see in the hair looks, the single strand of hair looks very big as compared to nanofibers. So nanofibers are very small, and as compared to the human hair. So human hair is about 25,000 nanometer wide. So you can fit many nanofibers into the human hair. So much small the nano material is. Now, when you look into the history of the origin of the nanomaterials, the first ever concept was presented in 1959 by the famous professor of the physics, Dr. Richard P. Uh, Feynman, and invention of the scanning tunneling microscope in 1981, and the discovery of fullerene, especially carbon 60 fullerene molecule. Fullerene is a case of the carbon molecule with 60 carbons in 1985 led to the emergence of nanotechnology. And the term nanotechnology had been coined by Norio Taniguchi in 1974, and there were plenty of room at the bottom. So there is the professor. So this origin was started began. Now it is given of the you know leading technology field. Now, why these nanos? Nanos are why required. Nanomaterials have superior properties than the bulk substances. So, the bulk substances properties are limited to one or two. But nano, when you reduce this bulk material into nano stage, nano state, the material's properties will be entirely different. It may find different applications in different fields. So nanomaterials have a very superior properties than the bulk material substances. Now, when you look into the mechanical strength, see mechanical strength of the only few metals are being known, like gold, platinum, zinc, iron, aluminum, etc. is known, or maybe even alloys are also known. Now, you can have a when you convert these materials into nano, the mechanical properties, mechanical strength, durability, and tensile strength, etc. So you can have an improved hardness and toughness of the metals and alloys, especially in the ductility and the superplasticity of the ceramics. So the mechanical strength, improved mechanical strength has been observed when the material in the bulk state is reduced to nano state. So the bulk state materials, let us consider an iron as an example. Iron or aluminum in the bulk state has poses some mechanical strength. So when the same material is reduced to nano state, the properties will be entirely different. It finds in more improvised mechanical strength properties. Now, catalytic activity, better catalytic efficiency through higher surface to volume ratio. So, nanomaterials possesses a very large surface area with respect to its volume. So, bulk molecules as compared to the nano possess a very less surface area. Nanomaterials possess a large surface area with respect to its volume. Surface is more with respect to its volume. So, because of the more surface, you find more active centers on the surface, and hence you find increased catalytic activity for the materials reduced to nano state. Now, electrical conductivity. Again, electrical conductivity depends upon the electronic structure. So, hence, in the nano, so you will find electronic structures which are very randomly oriented electronic structures. Hence, you find more electrical conductivity, increased electrical conductivity in ceramics. The substances which are not conductors in the bulk state may become superconductors in the nano state because of the spatial arrangement of atoms and the confined electronic structures and the different energies possessed in these electronic structures. So the increased electrical conductivity in the ceramics and nanocomposites, increased electrical resistance in the metals will be observed. So you find enhanced electrical conductivity when the material is reduced to a nano state. Now, thermal stability. So enhanced thermal stability, you find very enhanced thermal stability of the few of the metals when it is reduced to, especially in the nano state. Magnetic properties increase the magnetic behavior. Optical properties, so you will find in different emission and absorption bands. Spectral shift of optical absorptions, fluorescence, chemiluminescence, phosphorescence can be easily observed for the materials which does not possess any of the optical properties in the bulk state. When it is reduced to nano state, you can find an enhanced properties of the optical properties. So, not only optical properties, biological properties, increase the permeability. So, the let us say consider the cellulose. Cellulose possesses some permeability for some of the some sized particles, some salts in the bulk state. Now, when the same cellulose is reduced to nano state, so it may find increased permeability through biological barriers. So it may find different applications. Nanocellulose finds huge applications in the biological field. So you can find an increased permeability of the materials when it is reduced to 1 to 100 nanometers. Now the particle size is affecting the catalytic properties. So when you look into the ground bulk state of the material, so you find only few of the surface which is being exposed. And the bulk in the bulk materials, the properties are very restricted. So this restriction causes, why the restriction causes is that you can find only few of the atoms on the surface and most of the atoms inside the bulk of the materials. So that is why it is called as bulk of the materials. So bulk materials contains most of the atoms or molecules hidden inside this cased box rather than onto the surface. Now, when you break these bulk molecules and convert into a very small sized particles, let's consider. So all particles put together, so you find a large surface. Now, once this surface increases and the number of atoms present on the surface is also increases, and the activity of the materials will also increases. So you find larger surface area, increase in the larger surface area. Now once these increase in the larger surface area takes place, catalytic activity will increase because of the increase in the number of active centers present on the surface. So catalytic properties will increase when the bulk material is converted into nanomaterial. The properties of the nanomaterials can be different at the nanoscale because of the only two reasons. Two main reasons by which the materials, when it is reduced to nano state, finds different applications. The first one of the nanomaterials have a relatively large surface area. As I discussed in the previous, I repeat this term, they possess a large surface area as compared to the mass of the materials, that is the volume of the material produced from the larger form. So it possesses the so the properties of the materials are different in a nano state because of the two main reasons. First is when the material from is reduced to nano state from the bulk state, it poses a relatively large surface area. Surface area of the materials will becomes very large as compared to the mass of the materials produced in the from the bulk material. And the second one is nanoparticles can make materials more chemically reactive. So this chemical reactivity is due to the uh, possible arrangement of different energized orbitals, and the electrons possess a considerable energy in those orbitals, and the confinement of the electrons, that is the arrangement of the electrons, will different as in the bulk state of the materials, and it definitely affect the strength and electrical and optical properties of the materials. These two reasons are the main reasons why the properties of the materials in the nano state are different from. Now when you look into the classification, so nanomaterials are classified into four different categories. The first category of the nanomaterial is a zero-dimensional material. Now in the zero-dimensional materials, the length, breadth, and the heights. So you will have, so when the materials are made into nano scale, you will have a length, you will have a breadth, and you will have a heights. So the zero-dimensional materials are length, breadth, and heights are confined at a single point. That means a dot, a quantum dot. That dot is called as a quantum dot, and that is also commonly called as a nano dot. This dot is being generated by either by a single atom, or maybe a single molecule, or maybe a mixture of atoms or the molecules. So whose length, breadth, and heights are confined at a single point. Such materials are called as a zero-dimensional nanomaterials. Now the second one is one-dimensional nanomaterials. So one-dimensional nanomaterials, it has only one parameter, either a length or maybe a breadth or maybe a height. So either the length or the breadth or the height is fixed in one-dimensional nanomaterials. The length may be 1 nanometer, 10 nanometer, or maybe 50 or 100 nanometer, or height may be 1 or 50 or 100 nanometers, so on. So only one parameter is fixed in this case of a one-dimensional nanomaterials. Example is nanofibers, nanowires, and nanorods. So nanofibers, nanowires, nanorods, where the length and the breadth is fixed, or the breadth and the height is fixed. So the parameter, one parameter is fixed in this class of nanomaterials. So such nanomaterials are called as one-dimensional nanomaterials. And two-dimensional nanomaterial, it has only length and the breadth. Example, nanowires. So it has a particular length as well as particular breadth. Or nanotube, or maybe plates. So it has a dimension. So it is a certain size in length, let us say 50 nanometer in width, and 20 nanometer in the breadth. So the diameter is 20 nanometer, and the length is 50 nanometers. So such materials are called as in two-dimensional nanomaterials. Now, in the case of three-dimensional nanomaterials, it has all parameters of length, breadth, and height. So you can vary different length, let maybe 15 nanometer in length, 20 nanometer in diameter, and height maybe let us say 30 nanometers. So different nanoparticles can be arranged in three-dimensional mode where all parameters, length, breadth, and the height is being varied continuously, and such materials are common to the class of three-dimensional nanomaterials. So you will have four different types of nanomaterials: zero dimension, one dimension, two dimension, as well as three-dimensional nanomaterials. So you can see from the figure how the A is the like a quantum dot, or is like a dot where all parameters are fixed to one point, or it may length or breadth or the height. It does not have no. All are being fixed into a one point. Such substances. B, you can see a nano rods or nano wires where you can vary one parameter, either maybe length or maybe breadth or maybe height. And C, you can see two-dimensional nano plates, or maybe the matrix of nanofibers, okay, where the two parameters you can vary. In the plate you will have a length as well as and the breadth of the nanoparticles or the height of the nanoparticles. And D, you can see a cubic shape where all properties you can vary: length, breadth, and the height. So you can have a different length of the nanoparticles, different breadth of the nanoparticles, and different heights of the nanoparticles. And these particles may be either a single atom, mixture of atoms, or maybe an atom or a molecule. So it is different from different substances. So you can have four different class of nanomaterials. Thank you.